Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the fascinating world of databases. Before we begin, if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
That's right, Sheila. Your support means the world to us. Now let's continue our journey through the chapter, What is a database? Today we'll be exploring the exciting topic of types of databases.
I'm really looking forward to this, Victor. But before we dive in, I have a quiz question for our listeners. Here it is. What type of database would be best suited for storing and analyzing social network connections?
Ooh, that's an intriguing question, Sheila. It really makes you think about the nature of social connections and how they might be represented in a database. I'm sure our listeners will have some interesting thoughts on this. Let's keep that question in mind as we explore the different types of databases, and we'll reveal the answer at the end of the episode.
Sounds great, Victor. To start off, could you give us a brief overview of the main types of databases we'll be discussing today?
Certainly, Sheila. The main types of databases we'll cover are relational databases, NoSQL databases, which include document, key value, column family, and graph databases, object-oriented databases, and time series databases. Each of these types has its own unique characteristics and use cases.
That's quite a variety. Let's start with relational databases since they're probably the most well-known. Can you explain what they are and how they work?
Of course, relational databases are based on the relational model, which organizes data into tables with rows and columns. Each table represents an entity, like customers or products, and the relationships between these entities are defined using keys. They use SQL, or structured query language, for querying and managing data. SQL is a standardized language that allows users to interact with the database.
I see. So it's like organizing information in a spreadsheet where each sheet is a table and we can link information between sheets.
That's a great analogy, Sheila. It's very similar to that. The power of relational databases lies in their ability to maintain data integrity and perform complex queries across multiple tables. They're widely used in applications where data consistency is crucial, like banking systems or e-commerce platforms.
Interesting. Now you mentioned NoSQL databases. What makes them different from relational databases?
NoSQL, which stands for Not Only SQL, encompasses a variety of database types designed to handle large volumes of unstructured or semi-structured data. Unlike relational databases, NoSQL databases don't rely on a fixed schema, making them more flexible for certain use cases.
That sounds useful for situations where data might not fit neatly into tables. Can you tell us about the different types of NoSQL databases?
Certainly. There are 4 main types of NoSQL databases. 1. Document databases store data in flexible JSON-like documents. MongoDB is a popular example. 2. Key value stores are simple databases that store data as key value pairs, like Redis. 3. Column family stores organize data into columns instead of rows, which is efficient for certain types of queries. Cassandra is an example. 4. Graph databases are optimized for storing and querying interconnected data, making them ideal for social networks or recommendation engines. Neo4j is a well-known graph database.
Wow, that's quite a range. I'm curious about object-oriented databases. How do they fit into this picture?
Object-oriented databases are designed to work seamlessly with object-oriented programming languages. They store data as objects, similar to how objects are used in programming, rather than in tables. This can make development easier for certain types of applications, especially those dealing with complex data structures.
That makes sense. It seems like each type of database is designed to solve specific problems. What about time series databases? They sound intriguing.
Time series databases are optimized for handling time-stamped data. They're great for applications that need to track changes over time, like monitoring systems, financial trading, or IoT sensor data. InfluxDB is a popular time series database.
Now that we've covered the main types, I'm wondering about the challenges in choosing the right database for a project. What factors should developers consider?
That's an excellent question, Sheila. Choosing the right database is crucial, and it depends on several factors. 1. Data structure. Is your data structured, semi-structured, or unstructured? 2. Scalability needs. Will you need to handle massive amounts of data or traffic? 3. Consistency requirements. How important is it that all users see the same data at the same time? 4. Query patterns. What types of queries will be most common in your application? 5. Development paradigm. Are you using object-oriented programming? 6. Performance requirements. Do you need real-time data processing? It's also worth noting that many modern applications use a combination of database types, known as a polyglot persistence approach.
That's fascinating, Victor. It reminds me of the saying, if all you have is a hammer, everything looks like a nail. It seems crucial to understand these different database types to choose the right tool for the job.
Exactly, Sheila. That's a perfect analogy. Each type of database is like a different tool in a toolbox, and understanding when to use each one is key to building efficient and scalable systems.
Before we wrap up, I have a fun fact to share. Did you know that according to the DB Engine's ranking, the most popular database in the world is Oracle, a relational database? However, MongoDB, a NoSQL database, has been steadily climbing the ranks and is now in the top 5.
That is interesting, Sheila. It shows that while relational databases are still dominant, NoSQL databases are gaining significant traction in the industry.
Absolutely. Now let's get back to our quiz question. Victor, can you remind our listeners what it was?
Of course, the question was, what type of database would be best suited for storing and analyzing social network connections?
And the answer is a graph database. Graph databases are ideal for representing and querying complex relationships, making them perfect for social networks where connections between users are crucial.
Exactly right, Sheila. Graph databases can efficiently store and query the intricate web of connections in a social network, making it easy to find things like mutual friends, recommend connections, or analyze network patterns.
To wrap up, we've covered a lot today. We've learned about relational databases, various types of NoSQL databases including document, key value, column family, and graph databases, as well as object-oriented and time series databases. Each type has its strengths and is suited for different use cases. Remember, choosing the right database is crucial for building efficient and scalable applications.
That's a great summary, Sheila. I hope our listeners found this exploration of database types informative and engaging. Remember, understanding these different types is just the beginning of your database journey.
Absolutely, Victor. And to our listeners, if you've enjoyed this episode and want to dive deeper into the world of databases, don't forget to visit crashcasts.com and join our Discord community. Your support on Patreon helps us keep creating this content, and subscribing to the podcast ensures you never miss an episode. Thanks for listening, and we'll see you in the next episode of Database Internals Crashcasts.